Welcome back. I'm Alan Hall.
I'm Dan Blewett, and this is the Uptime Podcast, where we talk about wind energy, engineering, lightning protection, and ways to keep your wind turbines running. All right, welcome back to the Uptime Podcast. This is episode 31, and in today's episode, we're going to talk about a pretty wide range of stuff. First thing, New Jersey, there's some trouble afoot as legislators are potentially going to suspend some offshore wind work. Seems like the Fishermen Association is involved there. Also, a blade is broken on a Vestas V150 in Australia, so we'll chat a little bit about and go down the investigative trail just a bit. And we're going to talk a little bit about solar actually in today's episode. So panel efficiency is potentially improving with a new startup. So we'll talk about the implications of that. In our engineering segment today, RF absorbing material might be an interesting new development for wind turbines to prevent some of the interference with aircraft traffic control. Next, we're going to talk about split blades, which seems are going to be more and more important as these wind turbines get bigger and bigger. Transportation's always a challenge there. Without further ado, Alan, what's going on here in New Jersey?
Well, the democratic process is at work right now. There's a big push by fishermen that use the sea where the wind turbines are going to be installed off the coast. The New Jersey governor has been pushing to do a big offshore effort on wind turbines, but inevitably there's going to be an opposing group to that, like always, and the fishermen are complaining about it, and probably rightly so. They see it as another thing to work around and don't particularly want it, and they have a lot of clout. So it's going to be a battle in the legislature for sure. And now in this political environment we're in right now, we have to just sort of bear through it. I think once they get past November and into December, where the political atmosphere settles down a little bit and people can kind of get back to work, we'll see this even out. I don't know if this is a knee-jerk response to the governor's proposal. Kind of feels like it, but in any sort of dispute like this, the better approach is to attack it early. If you do think there's going to be some concessions that the administration is going to be willing to make, you better start now and start those negotiations to get to a final agreement instead of waiting until the project is approved and then fighting it then, because in most cases it's way too late. So I think the fishermen are just acting proactively, and rightly so, because that's the way state governments work in the United States for the most part.
Yeah, so the wind project in question here is the Ørsted Ocean Wind Project. And basically what they're alleging is the company has failed to deliver on some of its promises of economic development. They're supposed to hire union labor, provide grants, and, in general, boost the local economy. But, the head of the state senate, or the state senate president, has basically said that this isn't happening right now. And they're looking into whether Ørsted has, not made good on some of their promises in previous projects. So it seems strange to me as I read this article that it doesn't seem like this has been going on that long.
No.
I mean, and I know this stuff takes time, especially really big projects with lots of regulation and construction and logistics. There's tons of stuff at play. So to say like, hey, you guys haven't created new jobs yet, it's like, well, maybe this just takes a little more time.
Yeah, that's true. And I don't know if you've driven through New Jersey at any particular point, just get a feeling for the strength of the labor unions, especially in construction and things that are heavy industrial enterprises. And the unions are very strong in New Jersey. So it's not surprising that they have a sense of where the governor may be going and want to redirect it a little bit, or to get concessions out of the administration, which would make sense. New Jersey is struggling a little bit in the economy, and there's a lot of talk about taxation and millionaire taxes, and all these things are in turmoil because of the presidential election, state elections. All the elections are in November. So this just plays into politics right now. I like to see what happens in another 30 days, 60 days, to see if we're back to these sort of discussions or have we moved on. it's so crazy right now. Just watching, you don't even really watch any social media or television or anything right now. I was listening to the radio yesterday. Couldn't take it. It's just too much craziness, and I think this falls into that category. Let's just let it burn over for a while and see where we get back to.
Yeah, and of course, one of the specific complaints are that they have a facility need to be built, and they hired a German-based steel fabricator to do that. So they're like, hey, why isn't this using local
America
Jersey labor? Yeah. So I mean, I understand that it gets the ire of the legislators there.
Well, it should, I suppose, because if the roles were reversed, if this was happening somewhere else, well, and it's true. I think if there's a big push, and I'll give you the example. So Scotland has a lot of offshore wind turbines, and there's a big push by the UK government to get companies to establish themselves in Scotland to promote that industry. It makes sense, and it's one reason if a government's going to support that sort of industry, one of the natural outcomes is that they're going to try to grow employment for that industry in their own country. And that all makes sense. But again, I get back to, is this just part of the political atmosphere that we're in right now? Feels like it.
So moving on, a blade fell from a wind turbine in Australia. There were no injuries, but again, they're starting a root cause analysis to try to figure out why. And I know we've been reporting these each week. Of course, there's so many wind turbines in operation around the world. It's not like there's really that many of these incidences, but they do happen. So what was the story? Does anything stick out, especially that seems especially interesting here to you?
Well, I think this is a relatively new blade and a new site, and that leads to projections of something happened in the manufacturing process that didn't get caught, and quality escapes are serious concern. Manufacturing escapes are a serious concern. Or the secondarily, was it something in shipping where it got damaged in shipping? Another possibility. Most likely it's not a design error. Most likely not a design error. It's something in the manufacturing process. And those things take so much bloody time to figure out as to what happened, and the postmortems take up so many man hours to do that it's really advantageous to catch those kind of defects, those larger defects, which is what we're talking about, in the factory before they leave. It's to the point of, if it's in some case marginal, if you have them design one blade that's marginal, it's better to set it aside and make another one in a lot of cases than to suffer the consequences. There's this natural push, and you see it in a lot of industries, and not to say this is a particular case, but in general, that if you have a significant defect in a part coming down the factory line, that you want to try to quote unquote, rework it or repair it to make it usable out, because you don't throw it away, because you put so much time and money and materials into that part. You want to deliver it and get the check for that part. So you want to do whatever you can to keep the process moving. In some instances, it's the PR problem with a broken blade outweighs the cost of the blade to manufacture it. And you got to wonder if this is what's happening occasionally, because we know we have such good technology, Danny. You know how great technology we have to detect things in the human body today. Well, some of the derivatives of those things are how we check the structure of composite structures. So ultrasound, X-ray, we have all these technologies to go in and look on the inside where we can't visually see it. We can actually look inside the blade and look for defects. Why are we having defective blades raw at the factory? That doesn't make much sense to me. I could see it 20 years ago, not really today.
Yeah, and I'm curious, this one, the verbiage they use in the article is just that it fell.
Yep.
So I'm curious what that actually means. Like, did it snap in the middle? Did it come loose like from the root? It's not really clear. It's ambiguous language.
Right.
But either way, it's a lot of. I just want to see one fall to the ground. I want to see the aftermath of just, like, I want to watch it in slow motion. They need to do some testing on every possible thing and just get it all in slow motion, high def video, just so the world can see. So it's fascinating to see one of those huge blades just fall down, and just the way they. It's always interesting, I think, to everyone how big structures at high speeds just become like soft, right?
Yeah.
You see one of these turbine towers that are made of inch thick steel. When they get stuck in a monsoon or a typhoon or something, they just fold over like they're made out of aluminum foil. But anyway, I'm rambling.
No, it's right.
I just think it's fascinating. The power of these things is just crazy, and I just don't know what that looks like. See a whole blade fall out of its root. Yeah. So anyway, moving on. Sun Density, a solar startup, is touting a 20% power output gain to a specially coated glass that can, boost the efficiency and potentially viability of solar in lots of different places. So this caught your eye. And I mean, where are you on solar? We haven't really talked much about it on the show yet, but where are you with solar, and how do you feel about this? That seems like a pretty big boost. Is there a catch?
Well, I don't know if there's a catch yet, because we really haven't seen the technology being implemented yet. But essentially what it's doing is it's changing light from, or the energy, it's basically changing light. I want to describe this very simplistically, from the ultraviolet side of the spectrum to the infrared side of the spectrum. So there's a conversion that happens. It's taking the light in one frequency spectrum and shoving it into another that the solar cells can absorb, thereby opening a wider spectrum of energy into the solar cell, which it can convert to electricity. That
makes sense.
Okay, so
makes sense.
So there's been ways of trying to expand that usable spectrum that solar cells can turn into electricity. This is another way to do that. It really comes down to a lot of different factors. Can you manufacture it? Can you manufacture it in mass production? What does the cost of that look like? How does it last over time? Is there any sort of environmental factors that we got to be aware of? Is it humidity sensitive, temperature sensitive? Is it chemically stable over time? Does ultraviolet light degrade the thing? So there's a lot of little variables that will have to get checked to make sure that it's something of use. But the thought process is probably right, that you're just trying to use more energy. I think on the solar cell implementation aspect, here in Massachusetts, there's a lot of solar cells. In fact, the state government has really made a push a couple of years ago to get solar cells installed on people's homes. And then there's wide swaths of the countryside that have been converted from what was farmland into solar panel sites, fairly large sites, several acres at least, and to supplement the electrical grid. I'm not sure. Of course, when you see a 20% improvement, and you think, wow, that could be reality, right? That the 20% improvement can actually happen. You think to yourself, well, gee whiz, I've got all these acres and acres and acres of solar panel sites now that I could convert to be 20% more efficient. Maybe we should have waited a year or two. It's that sort of feeling to it, because the solar cells have been around a long, long time, and there's always been the discussion about improvements. But we never seem to get to that sort of critical stage. And there was for a while, because this is when there was allegations of China dumping solar cells in the United States, and back and forth. And the Solyndra episode with the Obama administration was about solar cells. And so there's a big push on at least the national and the state government in Massachusetts to push solar cells, and that did happen. The question is right now, is it paying off or not? And I haven't seen a lot of studies that say, yeah, this has been great for the countryside, or this has been great for the state of Massachusetts. I haven't seen that. And I should start seeing that, because it's been a couple of years. So I don't know. I think it's like a lot of technology industries. You really don't know till 4 or 5 years down the road before you see, is it worth it or not? You'll know. I think I always know when I see them and taking them down. That's when you know that the technology didn't really prove itself out, and it's costing too much money to operate.
Yeah.
Start taking them away. You're like, that's odd.
Where'd they go?
Right? I didn't see that in the newspaper about them taking these solar panels down. Yeah. That's when you know whether it's paid off or not, because then when the economics come into it, and the power company has to maintain them, and the local governments get involved, if the costs are outweighing the benefits, they'll just quietly disappear into the night. That's how we'll know.
All right, so moving on into our engineering segment, first thing we're going to chat about here is graphene nanotube technology that can potentially reduce radar interference in wind farms. So obviously this is an important topic because there's a lot of land that's essentially off limits for wind farm development because of the the RF interference that those big wind farms would pose to neighboring airports or landing spots or just like low altitude cruise spots for aircraft. So if we can find a way to reduce the radio frequency, I don't know, you have to tell me if it's reflections or just what they produce in general, then they can potentially build wind farms on these previously restricted lands. So how does this technology sound like it could work?
It does. There's been a lot of technology and money spent on graphene and sort of derivatives of that on sort of nanotube type applications from, man, you can name it. You just Google it, you'll see all the companies that popped up and the ideas to go use them and how it's going to make the world better and how it's going to make it more efficient just by using this carbon stuff. That's true, but again, we haven't seen it really implemented in a lot of applications where you thought it would have been, and it seems like a material that's looking for an application still, and it really hasn't taken hold of the marketplace. It's cool technology, but it just doesn't seem to ever get into common usage. Maybe it is, and I just don't see it. But I'm pretty aware of things that are happening on the high tech end of the world, and I haven't seen it used in large scales yet. But the concept is right. So what they're trying to do is absorb or redirect RF energy from like a radar site at an airport or a weather station, so that the energy doesn't come bouncing back to the radar to think it's a real storm or aircraft or whatever, even though it's fixed, right? So what tends to happen is that the radars see those turbines out there and it can't see behind them. That's where the trouble lies. So if you put an RF absorbent material on the turbines to absorb the energy, then you're not going to see anything behind it. I think it's the RF energy's got to pass through it, right? I think that's the kicker. The blades rotating were a problem for a while. You saw a lot of articles back in the 2000s about rotating blades and it showing up on radars. Here's the thing. Software fixes a lot of problems. And my guess is a lot of those earlier issues were resolved by some sort of software patch, so that, hey, that rotating thing out in 20 miles down the road, we're just going to ignore that, okay? And we're going to cycle it and know that it's a rotating blade, and we're going to ignore it. We'll take that out as noise. That's a software patch, and I think that makes a lot more sense than coating them with some sort of RF absorbent material, because sort of defeats the purpose. But if you see, Dan, you see a lot of applications. If you just Google, you can watch on science shows still about carbon nanotubes, how they're superconductive, how they got all these features, and you just don't see them. I mean, it's like a lot of high tech things you just never see. Hopefully there's application, but the cost of it is really driving it. It's not cheap material to make. And so small quantities are big dollars.
Well, and I think what you're saying about software makes sense. Where essentially just have your radar equipment separate the noise from the signal, right?
Yeah.
Like if we know there's constant interference coming from this neighboring wind farm, just
ignore it.
Tell the algorithms that this is not real, so this is noise, not signal.
Right. And
just move past it. I mean, I'm sure that's easier said than done, but
I don't know.
That seems like part of the move.
Some of the more recent software capabilities are amazing as to identifying what things are out there in the field. Like the Tesla software, if you've been watching Tesla on the driving software, that software is unbelievable. And the things we do with software today are just amazing.
So speaking of technology and blades, split blades are starting to become, looks like a little more prevalent, at least in the news, and it looks like more and more companies are working on this technology. And it seems really fascinating. It also seems really difficult. because you've got 150-foot or 350-foot wind turbine blade in 3 sections that then is going to be tensioned, have all those sections tensioned together and screwed together and then never come apart in 20 years. So, I don't know. The more I listen to you talk about engineering and think about the durability required over these really harsh environments, this seems just like a really tough thing to pull off. I mean, am I right or wrong there?
Totally right. It will be difficult to pull off because the long-term effects of rotating around and in hot, cold environments and salt water.
A lot of water and moisture.
Yeah, right. And you just don't know until you put it out there. And that's the trouble is I think on a lot of these designs, conceptually, structurally, the analysis are right. Yeah, we can do this. We can make this part. We can we can assemble it at the site, save a bunch of trucking, which is what this is about.
Yeah,
right?
It makes a lot of sense.
Yeah, right. Absolutely makes a lot of sense. So it simplifies all the factories get smaller, the trucking gets easier. It puts more restrictions on the assembly at the site. So you got to piece this thing together, and you got to have the right tools and technicians to do all this stuff. But I think there is a place for it. The tendency, though, of the marketplace is to say, unless someone has actually installed that technology out in a real environment for a couple years, I don't believe it. That's very typical of the wind turbine industry. We run into that all the time as a company, that unless somebody else has done it first and it's been out there for 5 years, then we don't want to go there. And which is a bizarre way of looking at it, because we do have more technology than we ever had before. So some of these variables which we don't have a good feeling for, we need to get a good feeling for. And we need to be able to test it in the laboratory and say, yeah, it's okay or not, instead of building it and sticking it out for a couple years. And then that's our test on a sample of one. It doesn't make any sense from an engineering standpoint. And I'll give you the rationale on this. If I have one super duper sample, which is what you will get when I make the one sample, on that one sample, every engineer involved with that thing is going to be on top of it, making sure everything is perfect. So that one sample most likely will pass whatever test is going to happen to it. That's what happens. Versus a manufacturing effort where there's variability involved and things change over time, and we're making these parts, and we're assembling on different parts of the world, and language barriers, you name it. There's all kinds of reasons: temperature, humidity, salt, pick it. That there's a lot more variables and more likely to fail in that random environment. But we don't test for the random environment necessarily. It's weird. And the engineers are sometimes the most vocal about it. Like, well, if company B didn't do it yet, then we're not going to do it. So the technology just dies. And I think there's a place for these split blades. And maybe you need to do it on a smaller scale first. I think that may be smart. Do it on a smaller scale and make some of these things, and then increase the size, grow it over time. That's probably the better bet instead of just going to like a 12 megawatt turbine with these split blades. That's probably not the right answer.
Yeah, well, it seems like, so this company that I'm looking at is Regen Blade. It's unclear where they've installed them. Mm-hmm. Like, they talk about their technology, they share some drawings, but the fact that they haven't mentioned on their website where they're installed makes me question whether they are installed anywhere. So I don't know. Maybe they could be. But, this kind of makes me think of like the aircraft companies, like Boeing and Airbus. They have so much, they just have such vast resources. We're like, yeah, let's throw $2 billion at this, prototype program, right? And I feel like that's what this is, where they need a company that big, like someone like GE or Siemens Gamesa that's huge, that can say, we can send a bunch of engineers to work on split blades. We'll make our own farm, put 10 of them in service, run them ragged, and if they blow up, they blow up. Like, It's not going to, break our company. Like, that seems, but if this is your company, it has to work, or you're done for, right? And someone's got to choose you. They've got to place big orders, and these are more engineering than companies that are already out there, and you're going to be more expensive than a LM wind power blade, right? Because there's more engineering involved. And smaller. So just it seems like there's a lot of hurdles for us this is my company to do this rather than just putting this in the hands of a big company. So maybe GE might, buy this company and say, hey, let's give it a shot and go with it. I don't know. But that seems like
I think you're nailed it, Dan. You're right on it. GE a couple of years ago was talking about essentially fabric covered blades, so they could make them in segments and come with a fabric. I don't know where that went. That has all gone quiet. I haven't seen that actually installed anywhere. I thought
they probably figured out.
Either it doesn't work.
Probably figured out it was not great.
Yeah, maybe, or they just didn't have enough drive to see it through. That happens in a lot of these projects where. That if the marketplace doesn't demand it, then I have to stop the production or the engineering spend on it, and they go to die.
Yeah, well, it is an interesting contrast, with our other podcast, Struck, that, there's like 20 companies chasing the electric vertical takeoff and landing vehicles, right? There's so many companies doing that, and all the big players have thrown some money at it as well, right? But yet here in wind, the split blade thing with just logistics of trucking being a nightmare, you'd think this would be one of that same kind of thing. Like, yeah, we all should want to be in this race. So find a way to make transport easier as these things get bigger, because at some point the blade length is going to be untenable for roads, right? Like you can't have a 200 meter long blade and truck it anywhere, can you? It's going to have to be rail and then what?
Well, yeah, that's
airlift.
They're going to go offshore, right? That's what the big drive is, to go offshore, because it takes away a lot of those impediments. Is that they can build a ship to carry that out to the site, where on land you're totally right, the roads are going to be a big impediment. But I think you raise a really good point, which has to do with just the technology improvements that tend to happen at the smaller scale. And there are not a lot of small scale wind turbines right now, right? We've talked about a couple on the show, but in terms of like going on Amazon and looking for, hey, I want my own personal wind turbine, there's not a lot of activity there, and there's not a lot of technology going on there. And it makes you really wonder why. And I think the reason, because a lot of technology comes out of those smaller companies. Just like here with the split blade, that the technology is probably going to come from a smaller company that can think outside the box, or just takes the box and shakes the hell out of the box and then says, okay, let's look at this from some fresh eyes. I think the driver, though, is the battery, the wall battery, like the Tesla wall battery, that if we have sufficient energy storage, I think a lot of smaller wind turbines are going to start popping up, because then it becomes, I can store that energy that I may not need right now for later this evening when the wind dies down, and I can be independent of the grid. And if there's one thing about the United States, being independent is on the top 5, right? And a lot of places in the United States would go off the grid if they could, but the energy storage is not quite there yet.
All right, well, we're going to wrap up today's episode of Uptime. If you're new to the show, welcome. If you're a regular here, thank you for your continued support. Please subscribe to the show and leave a review on iTunes, Spotify, or wherever you listen to podcasts. Don't forget to check out the WeatherGuard Lightning Tech YouTube channel for video episodes, full interviews, and short clips from each show. For Alan and all of us at WeatherGuard, stay safe, and we'll see you next week. Is downtime causing you financial pain and putting a stop to your power production for months on end? It's no secret, lightning strike damage is a major cause of wind turbine downtime. This damage is preventable with our easy-to-install strike tape lightning protection system for wind turbine blades. Our incredible engineering, build quality, materials, and edge sealants withstand up to 5 times more abuse in the toughest weather and lightning conditions. And we've got the research to prove it. If you're tired of constant downtime, we can help. Reach out to us at weatherguardwind.com and schedule a free call. We'll get your uptime back in no time.